So, without further ado, I'll ask our panel to briefly introduce yourselves. So,
Layla Entizam, EQ Consultant.
Nicole Washington, Director of Innovation and Growth with Octane.
David Friedman, Angel Investor with Tech Coast Angels.
Lolita Taub with Backstage Capital.
Steve Ardieri, AI Startup Advisor. And I'll just do a quick call out. One of my engagements, Cognitive World, which is a knowledge hub ecosystem marketplace for AI transformation, is going to grant the winner a 5,000 free membership to Cognitive World.
Great. Okay, so without further ado, if we could have Diagnose come up? No. Oh, sorry, Valhalla Healthcare. Good.
So ever since I was a kid, there was only one thing that I wanted to do when I grew up. And I didn't want to be an astronaut, I didn't want to be a firefighter, I didn't want to be president. All I wanted to be was a doctor. And so when I officially set on my journey into a medical career in high school, I envisioned and painted in my head this picture that my time and effort would be fully devoted to patient care. But instead, reality was a little more like this kind of picture here. Instead of spending most of my time directly face-to-face with patients, what I found was that myself and my peers would be spending more time on the computer than seeing and caring for patients directly. But my experience wasn't alone. All over the country, what we see is, according to research, that physicians are spending nearly half of their time on clinical documentation, and only about a third of their time is spent directly face-to-face with patients. And what we know what the AMA has done research on is that the less time that physicians are spending with their patients and more on the computers, it actually, which is, by the way, the EHR is the leading factor to physician burnout, it can really lead to some real-world consequences. And burnout's just one of them. We see higher rates of malpractice that can be connected to lower face time, worse outcomes and changes in chronic indicators, and actually a significant amount of waste that's contributed to the health system. My name is Alex Baki. I'm a physician, co-founder and CEO at Valhalla Healthcare, where my team and I were on a mission to leverage some of these advances in AI and machine learning technology to deliver the affordable, accessible, and effective healthcare that everyone deserves. And so here I was thinking, well, what am I going to do here in my last year of medical school? This isn't what I signed up for. Then one day I had this novel idea, an almost absurd idea, and that was, what if with the help of technology, in this case some of these machine learning models, if we could actually create a system that gets the patient to write the notes for us. And that's actually where it all started for our solution. And so we created a fully patient-driven, AI-powered intake solution that automates clinical documentation for healthcare providers. Think of it as a plug-in to the EHR, but also to the clinical workflow of the physician or the clinician in the best way possible, by not touching workflow at all. The AI models that we've built are used from taking data sets from the literature, from evidence-based research studies. So what we're able to do is then take the chief complaints of the patient, the medical history, and then what we're essentially able to do is see the patient in a different kind of lens. And so our purpose of how it works is, as soon as a patient gets an appointment scheduled, they'll be able to get a link that's directly accessed to our web app that's white labeled, in this case AI Med Clinic. From their chief complaint, our system will parse their chief complaint and then do investigate a little more of an investigation of the chief complaint for what we call the HPI. Now, based on that data set again, the system will dynamically adapt and ask certain questions based upon, again, the data set that that patient brings, and then converts all that information into a standard clinical note that we're used to directly into the EHR. And so what we've seen so far in our studies is we've seen a 30% reduction in EHR use, which is translated to about 720 minutes saved per month per physician. And we've also been able to accurately increase the accuracy of E&M coding as a result of collecting patient data. We sell directly right now to ambulatory practices in family medicine and orthopedics. With next year, we're starting to get into some partnerships for telemedicine and some EHRs. And while there's several competitors out there, including current day use cases like scribes, we're a significantly low cost compared to some of these higher fixed costs. And our main edge against technology, other technologies out there, is that our system is able to engage in clinical level intake outside of the exam room, so the physician can spend every single minute, every single second in the exam room, spending time talking with their patients on what really matters. And that is patient education, shared decision making, and even the physical touch, or the human touch of the physical exam. And this is just the beginning for us. We're collecting much patient-sourced data so we can track pain scales, we can track review system changes. And what we're wanting to do is then tie and strengthen a lot of our supervised models with diagnostic gold standards to strengthen predictive abilities, potentially, with the constellation that a patient brings. We're Valhalla Healthcare, and with our tech, what we anticipate to do is to do a little bit of less of this, so we can do a little more of this. Thank you.
Specifically building predictive models for cardiovascular disease. I've also worked at IBM Watson for their cognitive assistant as well. And it was really through my conversations with my co-founder, Abood, at Berkeley, who was finishing up his law degree by training, but in practice, he's owned and operated urgent cares and pharmacies, and specifically, he's owned and operated a medical billing business. And he was speaking about the pain points he's experiencing within medical billing. And I was actually surprisingly fascinating about the types of complexity and the root causes that exist within the inefficiencies in medical billing. So we came up with Diagnos. So let's talk a little bit about numbers since I'm an engineer. So US healthcare reimbursements, $2.9 trillion annually. So that specifically involves going from an insurance company to a medical institution, $2.9 trillion. And now we reduce this to $470 billion of how much is involved with logistical processing for the US healthcare system. We're targeting the core and the root and the kind of seed of this, this market, which exists in medical coding specifically. And medical coding is very error prone, as many people know. Specifically, it's, the error rates are at, if this clicker works, maybe it doesn't. Doesn't seem to be working. Yeah. Can someone help with the green button here?
I'll give you money if you can fix this.
Sure.
But you got to give them 50% of the company.
It's amazing. It's amazing that we still haven't figured out AV problems yet after so long, right? Yeah. Pause my
Yeah,
time?
right.
Okay. Sure.
It's like a soccer game. We'll give you
no
extra
worries.
minutes.
Don't expect that in real life, though. Yeah. Yeah, exactly. You need the receiver back too, or no? Okay. All right.
You want to do a little dance or something?
Yeah,
Sure.
right. You know any good jokes?
Not really, honestly. I can talk about, oh, well, I was going to talk about some interesting machine learning work, but I guess I'm...
Tell us about yourself.
Sure, I could, yeah, if you want. So traditionally, I'm more of a computer vision person. So I've done both computer vision and NLP. You can read some of my papers in Nature Digital Medicine. We were specifically working in Echo, for any cardiologists out there. So different prediction tasks in Echo. I've done some work in MR and CT as well. And then NLP, I've done work related to medical reports. So this is kind of the extension of some of the research I was doing at Berkeley. So that's what I like to do for fun. You know, I've been in the Bay Area for 10 years. And then like a year ago, I decided I need to pick up surfing. I've been in California for so long. So I just recently started picking up surfing. So I'm excited about that. This is becoming more than a pitch competition, I guess.
So did your work at Watson kind of contribute to deriving insights from unstructured data? And what's the percentage of unstructured versus structured is, you know, in healthcare? I mean, the usual ratio is 90-10.
I completely agree. So that's a really good point. So I feel like a lot of ML applications have been okay, but let's put it this way. There's a lot of fluff out there when it comes to people developing ML for various purposes, right? And this is why I specifically was most excited about medical billing. Someone's asking me like, why medical billing? One of the reasons why is it's a foundational process in terms of a translation process. You're trying to encapsulate what is happening behind the scenes, right? So that's why if you can basically develop the machine learning to fully capture that, both unstructured and structured data, then you can do a multitude of things from patient care to a lot of other different prediction tasks. So that's why I view it as kind of like a root and foundational problem at the end of the day. And then like you said, like most applications that exist right now, they're using only structured data. They're not using unstructured data. mainly because it's tough, right? And the things that we're doing today also.
It's too bad.
It's yeah. Oh, I think I popped up. Yeah. Okay, sure. This is a different version, not the PDF. Okay, all right. Well, I'll just roll with the punches here. Let's go. So, $15 billion medical coding. We can continue that discussion. So the error rates, excuse the fonts, I think the font just changed for some reason. The error rates are 30%, which is shocking, 3-0. And what does error rates translate to? Basically, it translates to approximately, by some studies, $210 billion in the US in lost reimbursements annually. Now the problem, so medical coding, let's remind ourselves what medical coding is. Imagine on your right side you see Barbara, she's sitting in front of a desk, she's reading medical reports, she's reading structured and unstructured formats, trying to figure out what happened, both procedures and diagnoses, and translating it to these alphanumeric codes. She's maybe trade school trained, maybe she has certifications that are applicable, maybe she doesn't have all of them. And so you can easily start seeing where the problem arises from. So coding errors translate to three main things. Underpayment, so loss of revenue. 2, delayed payments, so specifically cash flow problems. And overpayment, which can expose you to litigation and audit risks. So one of the medical businesses that we're dealing with, Dr. Hadery in the Bay Area, he lost $10,000 just because the biller didn't use an updated code, for example. So this is real. So the machine learning applications that the models that we develop are leveraging advances in deep learning and NLP. It's built from the ground up, as you mentioned. Unstructured data is incredibly important, and we're trying to really understand kind of the semantic information, both on multiple levels. The medical report as a whole is a very information-rich document for prediction tasks for diagnoses and procedures. So what this translates to for the provider, who's the end user, is we utilize and integrate with any EHR. So currently we have a partnership with Dr. Chrono, and we're integrating with different EHRs and provide a prediction panel on different things such as diagnosis coding, E&M coding, CPT coding, and documentation improvements that give you suggestions at the get-go. So we sell to medical businesses. Our pricing model, which we can discuss, is 0.5%. So what we're really trying to focus on, which 0.5% translates to a 10x value that we're providing to the provider. And the benefits include an increase of revenue and decrease in audits and litigation. So why now? I think a lot of this, the purpose of this, the conference is really about this. Healthcare is at an inflection point in terms of the systems available, the data available, and the machine learning models as well. Where do we go from here, essentially? What we're focused on is specifically the analytics engine. So how do we develop the best analytics? How do we develop the best models to truly understand what's happening underneath? So this can be translated to applications for medical businesses, for payers as well. We've signed a partnership with a clinical documentation, $100 million startup right now that they're interested in as well. So there's a lot of different applications that we can go from here as well. But we're focused on medical coding at the get-go. So yeah, it's Diagnos. Sorry for the thrown off pitch, but feel free to contact me at my
You did
contact
great.
Yeah, thank you. Sorry for the technical glitch.
No worries, yeah.
Healthcare is by far the most targeted sector. And the cost of breach is $408 per breach record, which is twice as that of Next, which is finance. So John Podesta, Target, Home Depot, Google, Facebook, all of these are victims of phishing attacks. And this is what I just mentioned. The cost of breach in healthcare is by far the highest in the industry. And why does this happen? Because 93% of all breaches start with a phishing attack. 2 years ago, it was 91%. With all the hoo-ha on phishing, you would have thought it would have gone down. It's actually gone up. And more than 90% of email-based attacks involve phishing and no malware, no virus or anything. And you'll see these numbers with everyone, Proofpoint, Mimecast, Microsoft, Barracuda, whoever does anti-phishing, you'll see the same numbers. What's the difference? 100% of anti-phishing services today are deployed in the cloud. We are deployed on your laptop and desktop, which is called the endpoint. And why is that important? It is important because hackers over the past 2 years have been using cloaking. So what that means is, check this. On the right side is the phishing link when you open on your laptop. On the left side is what services like Proofpoint and Mimecast see in the cloud. They're not able to see the phishing page. you have to be on the endpoint to be able to see the phishing page. And this is a very recent trend. And the other attack is where they're attacking employees on their personal accounts, either at work, outside of work, or at home. And John Podesta is, I don't have to tell that example, he got phished in his Gmail, and then they used that to get into the DNC. So you cannot buy Proofpoint or Mimecast for your Gmail to protect the organization, right? So that attack vector is completely open. So what do? We are the world's first anti-phishing that runs on your laptop and desktop, and it uses deep learning computer vision in real time, directly on your device, and at the point you click on a link and open in your browser, we will look at the browser tab in 1 second, and we'll know it's a phishing attack, and we'll shut it down. All of this happens. So I'll show you an actual video from just 2 days ago. Supposed to play. All right, so this is an actual email. You see that it's December 10th. Yeah, I'm trying to open that email in my browser. I've got my software running on the machine. I open it. Microsoft didn't stop it. Google did not stop it. We stop it. We shut it down. You see Avast, Web of Trust unknown. Avast says unknown. Bitdefender says safe. McAfee, I don't know what they do. They also say no phishing. So this is the state of affairs today, and that's because they're all in the cloud and they're still relying on blacklisting and IP reputation, and they're not real time. We are real time on your device at the point of click. And this is on that same link 50 hours later. It's still not blacklisted. And on the left is Google saying no unsafe content. In the middle is Wade Secure, another big brand, saying it's all okay. And on the right is that green tick mark. Only 3 out of the entire 69 major vendors say it's phishing, and that is after 50 hours. By then, no wonder Marriott breach happens when that stays undetected for 4 years, right? This is what happens. So we are backed by some very well-known early-stage VCs as well as cybersecurity investors, including Ron Gula, Chris Weissopol, Highland Capital. And just a couple of hours ago, we got offers from all of these big brands. So we're going to be starting deployments starting January. We are already we already started pilots in 2 other major hospitals, and I'm talking only healthcare. We are also in finance and other companies that we're talking to. And we just launched last week, by the way. And this is our advisory board, amazing guys. They are helping us every step of the way. Ron, Chris Weissopol, very big names. Charlie there, 35 plus years at NSA. Steve is the world's first CISO. He's a former CISO of Citibank, JP Morgan. Most of you some of you from CIO, CISO background will know him. And we also have folks from the business side. And we were part of Mass Challenge, which is the world's largest accelerator in 2017. And we just made it into Mass Challenge Health Tech for 2019. That's the 5 offers that we got. We were part of Highland Capital Cybersecurity Accelerator in Highland in 2016. This was during the elections. We stopped the same attack patterns, APT28 and APT29, that the FBI reported with Russian interference. And we won this competition with Google in 2017 in cybersecurity. MIT featured us as top 10 outstanding companies in 2018. RSA picked us up for next year as top 50 most promising companies. And Amazon AI is collaborating with us because we are consumerizing that deep learning model. So I'm sure most of you here know MXNet. Our product uses MXNet on the CPU, on laptops and desktops, and we are the world's first to do that. And so Amazon, we are consumerizing their software there. So that's fine. Thank you.
My name is Julie Collins. I'm the CEO and founder of Vivid Genomics, and our goal is to accelerate neurodegenerative disease drug development. My background is in genetics. I've always been fascinated by genetics and the information that it contains, and I have a PhD in population genetics from the University of Chicago and about 10 years of experience in business, first as a stock analyst covering life science tools and molecular diagnostics companies, and then in senior marketing strategy roles at Illumina. And over the course of my career, I've become an expert at matching large unmet needs or identifying large unmet needs in healthcare with opportunities where genomics could actually make a very big difference in those areas, and then selecting the right genetic tool to apply to the problem. And at Vivid Genomics, we are developing genetic-based tests to help pharma companies identify the right patients for their clinical trials to improve the probability of getting a drug approved. So I want to start by talking about Alzheimer's disease. At this conference, a lot of the conversations have been around how can we provide better care to patients. And in the case of Alzheimer's disease, there is no drug that can actually change or slow the onset of the disease. It's the only major disease that has no such drug. There have been about 147 failures in the last 20 years, so this field is notorious for drug failures, and it's also extremely expensive even by drug development standards. So the estimate is about $5.5 billion from preclinical through phase 3 per drug, and yet pharma companies continue to innovate and develop drugs because the unmet need is so great. There are 50 million people worldwide living with Alzheimer's disease, and that number is expected to triple over the next 30 years. So the question then is obviously, why have all of these drugs failed, and what can we do about it? We believe that a large part of the problem is that patient variation is extremely hard to characterize. There are patients most patients actually have multiple forms of dementia, or they have different subtypes of Alzheimer's disease, and they have different rates of progression. And all of these features can negatively impact the outcome of a clinical trial. And we know that this variation exists, so at Vivid Genomics, we're identifying this variation. This approach is standard in the field of oncology using precision medicine for cancer drugs, and we believe this is the future of neurodegenerative disease medicine as well. So these 50 million people that I talked about are not just colored stick figures. They are our spouses, our parents, and our grandparents. And our vision is to identify all subtypes of dementia and Alzheimer's disease to enable pharma companies to develop drugs that work optimally for every patient so that every patient has a drug that works for them. We're leveraging our unique expertise in disease biology, machine learning, and genetics to identify the right combinations of genetics that can identify characteristics related to brain disease to get to a test to understand what is driving the disease. Often these characteristics there are no methods to identify them, or if they are, they're extremely challenging and expensive, and having this information helps pharma companies make more informed clinical trial design decisions. So we're helping pharma companies reduce enrollment time, reduce trial costs, and most importantly, to both the pharma companies and to patients, get to a drug that works. So look at this photo. We know that genetics makes a difference. So this is a family photo that is not just any family photo. This is my family. This is my mom in the blue and the yellow at the top. So there are clear genetic underpinnings and features that are in common here. Genetics are important because that is where biology starts. But not all features are, in fact, most overwhelmingly, most features are not driven by a single gene. We know that there's multiple genes that each contribute a small amount, but in combination actually have a big effect. So we're applying complex statistics to features that we know are important in brain disease to identify the variants or the genes that are important. And then applying machine learning to identify and derive the strongest combination and weighting of these genes or SNP variants to get the best test and the best outcome. In practice, our tests start with the genetic material present in blood. Once we have the genetic material, we can run multiple tests which give multiple pieces of information that pharma can use to enroll patients and stratify for their clinical trials. We've developed 4 tests to date. The first one for amyloid, we are in the process of validating right now, and it will be our first commercial product. We also have collaborations with the NIH and 3 other collaborators for access to gold standard samples and data, and we have lined up validation studies for the next 3 tests starting early next year. The market addressing pharma companies with our clinical trial tests is worth about $1 billion, while the opportunity for companion diagnostics to predict drug response for an on-market drug is about $50 billion. So by engaging with pharma companies early, we have high revenue upside with relatively low risk, where one of our tests becomes implemented in a clinical trial that's successful. We have really strong customer demand. Pharma companies are hungry for something that can improve their chances of getting a drug approved. These are companies that we've had multiple conversations with about implementing our tests in their clinical trials. So far to date, we have developed 4 tests, started our company, validated our first with $500,000 of funding. We have an aggressive timeline for commercialization in 2019, and given our track record to date, we're confident that we can achieve this. In addition to myself, our team is experienced at the intersection of disease biology.
Just so you know, that's 5 minutes. There.
Okay, thank you. Our company is expert in the intersection of disease biology, genetics, and commercialization, and we're confident.
We're gonna have. I'm sorry, we're gonna have to wrap it up.
Okay.
Right. You can one more. One more slide? You done?
That was yes.
Oh, great. Okay. Thank you.
Thank you.
So Julie, I'll let you go first.
Okay, sure. Great presentation. Thanks. I really love how you incorporated your personal story. So what, outside of capital, what do you need to be successful?
Yeah, so we have a lot of expertise in genetics and on the scientific side. What I'm really looking for, and this was one of the slides that I had to skip over, is an external board member who has expertise in pharma services and clinical trial design. I think that's a component that would be really, really important, both as we're thinking about moving forward and having expertise and connections.
Yeah, I thought it was a great presentation, too. You covered all the points that I would be interested in. What makes you believe, do you have any IP for one thing?
Yeah, we have a provisional patent submitted for both our progression rate assay and for amyloid.
And why do you think you would be able to sustain and have this competitive advantage going forward, where this is a big issue, we know people are working on it, we've heard these pitches before on the diagnostic side. Why can't other smart people do the same thing, notwithstanding the patent?
So there's a couple things. One is that by having, we've been talking at this conference a lot about the commoditization of data. I think that's true for really large data sets around genetics, but what's really key is having gold standard samples that you have very well phenotyped. That is not a commodity. And so by having the relationships that we have with pharma companies and with academics, we have access to that data, and that's not trivial. The other thing is that being able to commercialize a product and understanding your customer and being able to actually solve a problem that they have is not something that I've seen our competitors be able to do as well.
So Julie, I have had the advantage of seeing you before at the Ad Astra event last week, and you did a great job there, and I know for a fact that you have a great support system for what you're doing. What I would like is if you could expound a little bit on the conversations that you've been having and maybe give us an example of maybe how excited folks have been about this, just to bring us into your world a little bit.
Sure. On the customer side or on the...
On the side of the conversations that you were having in that last slide about, I guess, with the government, biopharma, yes. Thank you, David, I appreciate it.
Yeah,
biopharma conversations.
Yeah, I thought it was really interesting. So we actually started with the amyloid test because the alternatives to testing with genetics or a blood-based test are either a lumbar puncture or a PET scan, which is extremely expensive. So that was where we started. We knew that we could do better from a cost and a challenge perspective than those two tests. But when we started talking to customers and saying, this is what we have, what do you think? We're also thinking about developing these other tests for comorbid pathologies and for progression rate. Is that something you'd be interested in? And it was like overwhelmingly, you could do a test for progression rate? That's incredible. That would make such a huge difference. It would save money if we excluded them, or we could include them but then stratify. It was like, there was a ton of excitement. So the challenge or I guess the balance with speaking with pharma is that the sales cycle is long. And so that's why we're developing, and building these relationships now, so that when we have a test that we're ready to commercialize, we don't have to wait from a year at that point. But at the same time, it's like you don't want to go too early before you have something that they want. So that's what we're working on.
It seems like the more personalized the drugs become, the more expensive they are. So my question is, how are you addressing everyone's concern, Alzheimer's aside, no treatment, for the cost of the drug? In other words, is this going to cost more? And we can have the argument, is it worth it? Sure, if your husband has Alzheimer's, and we don't care what it costs. But we do care what it costs. And it's a big deal. So the technology's fabulous. all the bells and whistles are fabulous, but right now the conversation's about money. So is this going to cost more?
I don't believe that it will cost more. I think that historically, some of the challenge with incorporating precision medicine and drug development is that companies are reluctant to say, you know, I only want to make a drug for 10% of the population, right? It's just not worth it, or it's going to be expensive. We're in a situation with Alzheimer's disease where there is no alternative. There's nothing else. It's not like there's chemotherapy for Alzheimer's disease, right? So pharma companies are open. They're saying like 5 to 10% of the population is great. On the other hand, the drug development process is so incredibly expensive for Alzheimer's disease that anything that could reduce that or accelerate the time or increase the probability of the drug being successful, I think will ameliorate some of those costs.
So fantastic presentation, Julie. So, and when you look at the track record, you know, with those 150, I mean, the numbers involved, it seems like this is like the perfect storm for a change agent. And really, I know you look. This is what you leverage. You're really looking at the combinatorial, right? The neurobiology, the genomics, the applied machine learning. And from what you've seen so far, why the receptivity, the pharma companies are saying, hey, let's give this a try because we failed miserably. Is that correct?
Yeah, absolutely. So we've had, you know, just as an example, so we presented at an international conference, the clinical trial in Alzheimer's disease, and it was where all of the major companies presented their most recent trial results, and some of them even discussed why their BACE inhibitors have failed, for example. And for the meetings that we requested, we got every single one of them. So they are keen to innovate and try something else, right? Like the definition of insanity is try something over and over again and expect a different result. And so they're open to trying something new and looking for innovations to improve their trials.
So I went to the school in a very competitive country. I was among the 30 people between the 1 million people taking exam. She knows about it. So I went to Sharif University, and then I got my electronic degree from there. I came to US. I did my PhD. Before I did that, I worked for HP to design the EKG monitoring system. I'm very familiar with all different kind of biopotential signals. I started from there in the PhD. I did the biomedical engineering. I did in 1991, I wrote a neural network program to detect epilepsy. At that time, when I worked with a doctor, and he was very happy, nobody else was doing anything similar to that today is very, very hot topic of today conference, 1991. So during my PhD, I also modeled the balance control. So I feel that instead of looking at one of the biopotential signals, we have to look at all the sensory input that we can take advantage of it. And the last part of my presentation, I come back to this. Why this is very important? So having some control and doing something about it after AI make a decision. So let's say among the audience, I know that side is dark. I'm not going to see all of you, but please raise your hand if you know somebody had a heart failure or heart attack, please. In your family or in your co-workers, yeah. So we will see that this market is a very big market. That in my own family, just in 2018, one of my best high school friends died because he had no idea that he had some issue with the heart. He may have had some pain at some point, but the point here is that he passed away because he fall down, and 12 hours later they find his body. So he was same age as me. So, and based on the based on the numbers, 1.4 million Americans experience a heart failure each year. So, and 500,000 die. So that shows that based on the Society of Heart Attack Prevention and Eradication, it shows that some of them, they didn't have any idea that they had a risk factor for their heart. So, so the risk assessment method that we use for screening should become little more comprehensive than just the cholesterol and those type of things. So the early diagnosis of atrial fibrillation can prevent formation of blood clot and eventually a stroke. So for another quotation from another doctor from the Sharp and UCSD is that for syncope patients, the long-term continuous monitoring is a must for efficient diagnosis because they lose the conscious. So, and the need for cost-effective continuous long-term monitoring has been recognized in the last 2 years, and they have been assigned some reimbursement code from insurance, which shows that they find out this is the issue. That the problem is that the reimbursement value compared to the cost of having long-term monitoring, let's say for 30 days, is not working out. The numbers doesn't match. So what's the solution? So the solution is that we are providing remote, continuous, long-term monitoring of your heart, like let's say for 30 days. And this is only happened because of using the neural network algorithm for the automated detection of heart arrhythmia.
Excuse me, but I need to interrupt. The 5 minutes is up. Yeah. So I'm sorry.
Okay.
Okay.
So I think this slide maybe brings some of the questions that you want to ask. So.
Okay. Thank you. Could you have a seat over there, please? All right. And you know, I'm sorry we had to interrupt, but we had to stay on a schedule.
Sure.
So you know, obviously some of the issues with. So can you specifically state in one sentence the problem you're trying to solve? Because you mentioned syncope, atrial fibrillation, chronic heart failure, heart attacks, et cetera. It's not clear to me, and when you say heart monitoring, that means a lot. So what is the problem you're trying to solve?
So our neural network are capable of classifying all the heart arrhythmia that is possible. Like, let's say there are 14 different type of heart arrhythmia that we can detect.
Okay, so you have a remote, an Internet of Medical Things, in this sense, remote sensing technology to monitor for arrhythmias.
Yes.
Correct?
Yeah.
Okay.
My name is John Ikudaisi, and I'm CEO and co-founder of XB Health. XB Health is a digital health platform for orthopedic recovery. So before I get into just how we help orthopedic recovery, I'd like to talk a little bit about my background. I was born and raised in London, and my family have a home health company. And this kind of allowed me to really get hands-on experience with patients in the home setting and really understand what drives, non-compliance when it comes to physical therapy in the home setting. The second way I was introduced to the problem is I used to be a former athlete, and I've been through physical therapy, and it is not fun. And going through that process, I realized that there is a huge disconnect between the patient in the home and the healthcare provider. So essentially, patients aren't compliant. Clinicians experience, issues with patient adherence all the time. But looking at physical therapy in particular, 70% of patients don't fully comply with their plan of care. This, of course, leads to prolonged recovery, which then leads to extended recovery and expenses. Currently, there's 8.5 million orthopedic surgeries that occur in the US, and this is growing. Why now is a perfect question. So our company is positioning ourselves to really improve value-based care. There's currently a shift between, fee-for-service to value-based care. And with this shift, the healthcare providers are being incentivized to improve patient compliance as well as improve patient outcomes. There's current solutions for post-surgery at the moment, which, as you can see, can be rather expensive, moving from inpatient rehabilitation facilities which would be in the hospital, for example, to skilled nursing facilities, and then, of course, the most affordable would be home health care. So this is where XP Health comes in. We improve healthcare outcomes for hospitals and clinics by optimizing recovery for patients. So our solution is 3 parts. It's a mobile application that the patient uses, as well as a wearable device, and we're hardware agnostic, so we can pair with existing wearables, and then the healthcare provider has a web dashboard. Now, taking a look at our current process, we want to be there from day one. So the minute a surgery is scheduled, the patient will be able to have the XP Health app. Then we help them prepare for surgery. Studies have shown the better prepared you are for surgery, the better the outcomes. After their surgery, they are able to use the mobile app along with the wearable to track their physical therapy at home. The healthcare provider is able to remotely monitor, and of course, the patient, because they're compliant, recovers faster. Now, this is just a preview of some of the features. So we have the wearable that connects to the mobile app. They get daily reminders to do their exercises, so they can no longer use "they forgot" as an excuse. We have exercise demonstrations that allows them to view their exercises. And we have a calendar system that's integrated with this, as well as a messaging portal. Now, part of our secret sauce is we have machine learning algorithms to help track all of the patient's movement. So this is just a screenshot of some of the data that we collect. So as well as pain tracking, we're able to track a patient's reps, form, speed, and range of motion, which is very critical when it comes to orthopedic recovery. Taking a look at our market size and potential revenue, using the number of surgeries in the US along with our retail price, we could potentially make a revenue of 20.5 billion servicing all surgeries, 2.2 just focusing on orthopedic surgeries, and 431 million focusing on our beachhead market of knee and hip surgeries in the United States. How we make money is fairly simple. We have a SaaS model, which is our main model for going to market. We focus on servicing orthopedic surgeons and groups, hospitals and surgical centers, as well as home health companies, which have shown a lot of interest. And then we'll have a wearable that retails at $59.99, which is much below the current market price. Also, this wearable will be able to be worn on the wrist or the ankle that allows for tracking of numerous diseases and post-surgery for different surgeries as well. We've got great traction to date. We've been listed as one of the most fundable companies from Pepperdine this year. We have home health pilot and orthopedic pilot that will be commencing within the next month. We've spoken to over 100 healthcare providers to validate our platform, and we have proven recovery data from our initial pilot earlier this year. This is just a quick snapshot of our potential financials. Our margins are going to be rather big because of the fact that we're predominantly software company and focusing on our analytics, and we aim to achieve a revenue of 88.7 million by year 5. Taking a look at our all-star team, we cover everything from finance and healthcare, currently raising $500,000. Thank you very much. Open to questions.
Thank you. I wonder if I could ask you to have a seat.
Thank you.
I would ask you, did you play for Chelsea or
No, Austin.
West Ham? So as more and more orthopedic surgery is being done in freestanding ambulatory surgery centers, 17% of freestanding ambulatory surgery centers have an EMR. 17%. So the question is, how does this information integrate into the legacy EMR, particularly as more and more is being done in an ambulatory surgery environment where there is no EMR?
It's a very good question. At the moment, our web app is, of course, online, and it is a web app. So that kind of helps service all of the surgical centers that don't have the EMR. We're working on integration at the moment, but we haven't got a commercial version, but that's definitely something that we'll aim to incorporate as we
So if I understand you correctly, at this point, this is not integrated into the EMR?
That's correct, at this moment in time, yeah.
Okay.
What was the demographic of the population in your pilot?
So the demographic, I have a few slides, but never mind. Demographic, it ranged from 20 to 65. So it was rather large. There were 60 patients. Half of them were a control group. The other half used XP Health, and it was over 3 months. What we found was that patients spent 35% more time doing their exercises. They improved their range of motion on average by 15 degrees, and they performed better compared to the control group by 10%.
Yeah, first of all, I thought it was a great presentation. I've
Thank you.
rehabbed many times. I thought you hit all the points that I want to hear as an investor. So I feel pretty comfortable. Question I have is it reimbursable if I'm a patient? And number two, do I buy it myself? Is it a pull me strategy, or is it a push through the doctors? Do you sell to the doctors, the clinics? What's your marketing and sales strategy and relating to the users and the sellers?
Thank you. So B2B model, so focusing on servicing the healthcare providers. And part of the reason is that, and I've touched on the value-based care at the moment, is that the risk and the responsibility is moving from insurance companies to healthcare providers. So now, at the end of the day, there's going to be a bucket price of $30,000 for a knee replacement, for example. Instead of being able to bill the insurance company every time you see the patient, now the healthcare provider has to manage that $30,000 from beginning to end. So if the patient takes 2 months longer, they spend $40,000 to get better. That extra $10,000 comes out of the healthcare provider's pocket. However, if they recover, in $20,000, that $10,000 is pocketed by the healthcare provider. So that's kind of the incentive and our business model, focusing on B2B healthcare providers.
Go ahead, I'm sorry.
I'm curious about what the beta testers, the users, had to say. What kind of feedback did they have? Because even if I hurt myself, I'm very resistant to downloading an app, doing exercises. I'm very bad at taking my vitamins. So can you give us some feedback that you've heard from the people who would use it and feel this whole system?
Yeah, so we got 100% positive feedback. And I think the biggest reason we got that feedback is because currently there is no way to track any of that data at home. You go from having no information at all, being told to do knee extensions and having no idea if this is actually working, to patients now using it and being able to quantify and getting that biofeedback to say, wow, you've improved 2 degrees from a few days ago.
So what are some of the quotes from your users? Because 100%...
Positive feedback, yeah. I guess it ranges from, I feel motivated to continue doing my exercises to, this kind of reassured